All right, section 5.1, we were looking at addition and subtraction of integers. We had talked about integers. Remember, they're positive and negative whole numbers. And we had looked at several models. I'm just going to flip through the slides kind of slowly because we're going to see these models come again. We had the chip model. The idea of the chip model was that we put in these colored counters in such a way that we noticed that when we had one color counter of each color, we were able to cancel it out. It was a 0 value. And so then we had only one colored counter when we were done. In this case, it was the number 2. We talked about the charged fields model, which is very, very similar to the chip model, at least picture-wise on the screen here. Chip model is more hands-on. It actually has physical chips. The charged fields model uses pluses and minuses in the same way that the chips are used, though. All right, we had the number line model. This one's also a very interactive model that you can actually work out in class with kids walking around on a number line of some sort. And so we can also draw a visual picture representation of it. Positive moves forward on the number line, negative moves backward. Pattern model is the idea of establishing some sort of relationship with numbers that we know. In this case, it was 2 numbers that were added, and so we were adding 5 plus 2, 5 plus 1, 5 plus 0, and noticing the pattern went 7, 6, 5 on the side, continuing the pattern down into the negative numbers. So those are our methods, and we're going to see those happen again with subtraction. All right, integer subtraction. For any integers a and b, the value a minus b is the unique integer n such that a equals n plus b. Or b plus n is what I've written down. Same thing. So all this is saying is that if I have a minus b and it equals n, that this is the same thing as saying a equals b plus n. It's simply the amount that we need to add to b to get back to a. That's what n is. It's the amount that's missing. It's the missing portion. All right, we're going to do the same 4 models that we did with addition. We're going to do them with subtraction. So they take on a little bit different feel because we're subtracting, but there are similarities, of course. Oh, I'm sorry. I had one more theorem before then. I apologize. Okay, let's do that one. For any integers, a and b, if you have a minus b, it's equivalent to having a plus a negative b. And so you can use those interchangeably. So when you talk about subtraction, we also sometimes say it's the same thing as adding a negative. I'm sure you've heard that phrase before. That's what this theorem is talking to us about. And we can model this with a CHIPS model very quickly as well. And I think we'll see an example of that in a moment, although it's not quite the same. So let me actually show it to you here. All right, so let's say we had some examples. Let me do some numbers. Let's say we had 5 and we had minus 3, which is supposed to be the same thing as 5 plus a negative 3. And let me just use that colored CHIPS model that we did before because it's pretty nice for this. So what we do, if you remember, is that we draw a circle. And since the number 5 is positive, we put 5 positive chips in that, or 5 positive colored counters in that circle. And I think I used yellow for my colored counters that were positive, so I'll use those again. So I have 1, 2, 3, 4, and 5. The idea of subtracting 3 is the idea of removing. Subtraction is a removal. One of our descriptions was takeaway, right? Removing 3 chips. And this is removing 3 yellow chips because it's removing positive 3. So I can take 3 of these chips and I can remove them out. Or you could put big old X's over them if you'd like that notation better. So I take those 3 and I move them out, and the result, what I'm left over with, of course, is how many in there? 2, thank you. And they're yellow, right? So I have 2 yellow chips left over in here when I'm done, which is the answer 2. Now, I'm going to draw another model, and I'll draw it underneath this one, that shows what it looks like when we do the other way, that is adding a negative. And so this is actually a really good discussion since we discussed adding a negative last time, because we're going to talk about taking away a negative here in a moment. All right, so this says I have 5 yellow chips. That's where it starts out with, because I have 5 and it's positive. Right? And then this says I'm going to add in, which we talked about last time. We're going to insert something. But we're supposed to insert 3 negative chips. Well, what color did I use for negative? Do you remember? I used red, so I'm going to use red again. So I'm going to insert, because it's adding, it's addition, 3 negative chips. Now that does not look like the last picture that I had, does it? It doesn't. I didn't have any red in the last picture. And then what am I able to do with these pairs of chips that are not matching? Pair them up. And when I pair them up, they add to 0, right? So all 3 of these add to 0. So the only thing that I'm actually left with is the 2 yellow chips. Same thing as I had on the other pictured model. So in one method, I'm actually adding something in. I'm adding in the 3 red chips and I'm pairing them. In the other method, I'm taking out the 3 yellow chips. And of course, the net result's the same, right? 2 yellow chips at the end. All right, so now let's take a look. Our next example is what happens when we when we remove a negative. All right, so we've got our chip model. So we're going to draw our circle. And we're going to put in it what? What's our first thing to put in? What's this 5 telling me right here? What am I putting in my circle? 5 yellow. Thank you, Tier. I'm going to put in 5 yellow chips. Is everybody good with that? All right. Next thing, there's a subtraction sign right here. What does the subtraction mean for our model purposes? Take out or remove, right? This is take away. And this says I'm going to take away what? 3 what? 3 negative chips, 3 yellow chips, right? So I am going to actually remove 3 things that are already there. I'm not inserting anything. I'm not including anything that's not there. In fact, I'm removing 3 chips that are not supposed to be there. I'm sorry. I said that wrong. I was getting carried away. Let me just take a step back. Sorry. Okay. I need to remove 3 negative chips. I don't have my negative chips yet, right? Caitlin was about to tell me that. I could tell. I need to have negative chips that I'm supposed to be removing, and there aren't any negative chips in this circle, right? I only have positive chips. Is everybody good? Okay. So ignore what I said earlier. That didn't amount to anything, okay? What we are going to do, though, is I need to have those negative chips in my circle, and right now they aren't there, are they? So what am I going to have to do in order to have negative chips in my circle? Well, I need to put them there, correct? But if I just put negative chips in the circle, it's going to change the value of what's in the circle, correct? So if I just add 3 negative chips, that's not the same number 5 that I had before, right? This number in this circle right now is not 5. What would I have to do to balance it out? We will have to circle pairs later, potentially. But that doesn't change the fact that right now this circle is not 5. The value in this circle is not 5. Do you have an idea, Cassidy? Is it 8 in the circle right now? I think it's 2 in the circle right now. The answer's supposed to be 8. That's what my answer is going to be at the end, right? Yeah. What would I have to do to balance out just throwing negative chips inside of something? Say that really loud, Kaylee. Yeah, for every negative chip that I put into my circle, I have to put a positive chip to balance it out. So these 3 negative chips that I just added, that's fine. I can add the negative chips, but only if I add them in pairs with a positive chip. This circle still equals 5. Are you guys with me? Because I had 5, and then I've added in 0 pairs. That red-yellow combination, these 3 that I added right here, these are all worth 0. Yeah? So the value in the circle didn't change. I have to add in 0 pairs. So if I need to include something that's not in my picture, I have to add it in such a way that it occurs in pairs. All right, I'm going to uncircle those now because we're back to where I thought we were trying to get to before. This says, like you told me, that I'm going to take away, that's what's written in orange, 3 negative chips. What color are the negative chips? Red. So these are the 3 that I'm trying to take away, yeah? And they're actually in the circle so that I can take them away now. So when I do that, what's left in my circle? Somebody be bold. Tell me what's left in my circle. 8 yellow chips. Thank you very much. I have 8 yellow chips. That's what you told me I would have, right, Cassidy? And that's what we wanted to have, expected to have. And that's exactly right. I have now 8. Okay? But in order to have the right things in there to remove, I have to add them into the circle in 0 pairs. Okay, the same thing is going to happen on charged fields. So go ahead and draw the picture you believe will correspond to this model. And then we'll make sure that we all have the same thing. 5 minus negative 3. Same problem. It's just with charged fields. So it's pluses and minuses, not colored chips. All right, so how did you start? How many pluses did you put in there? 5. Fantastic. We had 5 pluses to start. And the description says that I'm supposed to do what? What does this minus right here mean? Take away. And this says I'm supposed to take away what? 3 negative chips. And there are not 3 negative chips in my diagram to take away, correct? So what do I have to do in order to get those negative chips there? You have to put them in balanced pairs. So you put in 3 pluses and 3 minuses. That keeps the circle the same. It's the value in the circle the same. And then I can actually remove the 3 minuses. They are no longer there. And the net result of that is that I have how many pluses in my circle now? I have 8. Okay, everybody good with that? The next one's a little trickier. It feels a little bit funny. It's a number line model. All right, so draw yourself a number line. And it's going to start basically at 0, and we're going to go out to 5. That part's just like we did before. But now I have minus a negative 3. And we know from the previous 2 examples, because we've done this problem before, the answer is supposed to be 8. All right, so the first thing I'm going to do is I'm going to draw a line representing that I've gone from 0 to 5. So here's the idea, and I'm going to do it physically in front of you so you can see what's happening. All right, so we talked about this before. We're going to move 5 across the room. So I'm going to do 5 rows of desks. So here's 1, 2, 3, 4, and 5. Okay? So here's what's happening next physically to the person walking in the classroom. This negative says turn around. Like this. Okay? And then this one says that I'm going to walk or move or whatever backwards. There's not a good way to draw this on your picture, but it works really well with the actual physical person moving in the classroom. So I'm going to walk backwards 3 rows. So here's 1, 2, and 3. And where am I in relation to where I started? I'm 8 away, right? I'm 8 rows away from where I started. So again, on the picture, I can't show that because there's really not a directional sense on the picture. But what we are going to show is we're going to show that we moved 3 more in this direction to land at 8. Minus a negative. Okay? That's the way that works in terms of a physical movement in the context. All right, we have one last one to do. That one is the patterns model. All right, so with patterns, we start by taking a value that we're able to do the subtraction of in positive sense. In other words, like we're going to do something like 5 minus 2, 5 minus 1, and 5 minus 0. All of those are whole number subtractions. So what is 5 minus 2? 3. 5 minus 1? 4. And 5 minus 0? 5. And then we move into the negatives. So again, I'm going to write down the 3 that we need to get down to the negative 3. But what we're going to do is we're going to look at the pattern on the right, not actually do the mathematics that we're thinking of on the left. The pattern is what we're trying to establish. So what's happening with the numbers on the right? 3, 4, 5. They're increasing by 1 every time, correct? So what would come after the next one? What's after 5? 6. And then 8. So again, we can look at this. Again, you're not going to want to do this with big numbers. That's not the point. None of this would you want to do with large numbers. But looking at these with small numbers establishes these rules that we have of, oh, minus a negative is just a positive, right? Because it's really just turning around and walking backwards. Minus a negative is really positive because I have to add in these 0 pairs and then I can remove the pieces that I don't want. That's what you're doing. right, any questions on this one? All right, the last thing in this section is a little bit order of operations. So you've seen this before, PEMDAS. Some people just remember it as PEMDAS. Some people remember an acronym. What's the acronym that you might have heard that goes with this? Please excuse my dear Aunt Sally. All right. Do you remember what the P actually stands for? Parentheses. Fabulous. So the first thing we would do in a particular problem, if we have anything inside of a set of parentheses that can be simplified, we do that first. So this is parentheses. What does the E stand for? Good. Exponents. If we have any exponents in our problem, they occur before, for instance, addition and subtraction. Now, might feel a little bit funny to you, but I wrote them this way on purpose. The M and the D are on the same line, and the A and the S are as well. Okay? We could have just as easily created an acronym that said PEDMOS. We could have, right? Or even PIMDS. Doesn't flow very well. There's nothing special that differentiates multiplication and division. So the idea that you have to multiply before you divide is not a true statement. When you're looking at the problem, if there is multiplication and division in the problem, you do it from left to right. So the M and the D are multiply, divide, but in no specific order other than left to right. And what about the A and the S? What are those? Yeah, they're addition and subtraction, or add, subtract. And again, there is nothing that says you should add before you subtract. You shouldn't always. What you should do is you should move from left to right. So both of these at the end are all about moving from left to right as you're working. Now, does multiplication occur before subtraction? Yes, definitely. But within the multiplication division category, it's left to right. Within the addition and subtraction category, it's left to right. We're going to do one example. I don't have anything with the parentheses and the exponents as an example because that's not usually the problem. Usually the problem is this left to right versus the add, subtract, multiply, or divide that causes students difficulty. So if you take a look at this problem, it is multiplication and division that we're going to be working with first. So what will the first thing we do be? Will it be the 6 divided by the 2, or will it be the 2 times the 4? Yeah, because it comes first. Okay, so as we're working, I'm going to do the pieces at a time. So this is 5 minus 2 plus, and then you guys told me 6 divided by 2, which is 3. And then now I have a 3 times 4. So what's my next step? The 3 times 4. So the 3 times 4 would be 12. Okay, so now I've got only addition and subtraction left. What's the first one that I'm going to do? I'm going to do the 5 minus the 2. So the 5 minus the 2 is 3, and then I'm going to do 3 plus 12. And then 3 plus 12 is 15. You have some problems in your book that are going to ask you something like this. What is the last thing you did? And the last thing we did here was what? The 3 plus the 12. Or you could say it was the adding the 12. One of those statements, okay? So that's what it's referring to. Now, I know that you probably could do 5 minus 2 plus 12 all at the same time. That's fine. But still, even if you did it all at the same time, the last thing you did was the adding 12 part. Are you guys with me? Okay. So don't get confused by that MADS business in the way that they structure that. That is for memorization purposes, and because you have to put them in there somewhere. It's not really an ordering to those. Okay? All right.